You guys have a little assembly 8th period, 9th graders only about how you're going to be locking up those phones next year. So only period 8's affected. I know. I'm sad as you guys. I'm only spending half the time with you tomorrow. That's sad. All right. So that's what's coming up tomorrow. All the rest of the periods are the same, 40 whatever, 2, 3. All right, spheres. Let me introduce you to a sphere first before we go with the surface area and volume. I'm sure we've seen spheres before, all right? There's only one part of a sphere I need you to be familiar with, and that's this part right here. Any idea what I call that? Oh, no wonder you're an honor. So smart. Radius, yep. It's the only thing you need. There's other parts, but that's the only part you need. Why? Watch what happens when I give you both formulas now. Surface area of a sphere, don't even bother looking on your formula sheet. This is the only one you need to remember for Friday. Only one. All right, so you might want to give yourself a little note here. Not on formula sheet. It is your responsibility. Only one that we're going to talk about. And I say it's not on there, but it kind of is. Take a look at your formula sheet. You guys have circle on there, correct? Area of a circle, pi r squared. A sphere's formula. Surface area of a sphere, 4 pi r squared. There you go. That's it. Now do you understand why you only need to know what the radius is? What's the only value I'm going to substitute in? R, radius, that's it. You don't need to know anything else except for the radius. So remember that as we try out the first problem here. Circumference of this rubber ball, 20 pi, what's the surface area? All right, so you just told me, hey, only thing you need is the radius. Well, didn't give it to you because we're in honors. That'd be a way too easy question. What did I give you, though, in this problem? I didn't give you the radius, but I did give you 5? Circumference. So, nope, not last unit. Oh, 2 units ago. Anybody remember that formula for circumference? I won't call it anybody and make it awkward. Nick?
Isn't it diameter times pi?
Pi d, good work. Pi d, so let's go to that formula. Circumference 20 pi is equal to pi d. What can I do on both sides here to keep moving? Oh, 16. Get rid of the pi's. So diameter equals 20. All right, what do you want me to plug in the formula for R now? 28, 10, thanks Tyler. Surface area equals 4 pi. Everyone all right on how I got 10? Using the circumference formula. Squared. Let's just leave it in terms of pi. Let's make our lives easier so we don't have to press all these buttons and show off our rounding ability. In terms of pi, 13. 400 pi. Some of you guys I know like to put the units on. Just be careful here. What type of unit should I have here? Centimeters. Yeah, darn right. We're back to surface area. Squared. All right, good work. So all I need is radius, and you're good. How about the volume of a sphere? That is on your formula sheet, so can somebody hook me up with that formula? Volume of a sphere. 14, your show.
4/3 pi r squared times
Do you have a different formula sheet?
4/3 pi r cubed.
Thank you. Good thing you get that one, huh? 4/3 and the cubed. Ooh, good thing we give you that one. Again, what's the only thing you need to plug in? Radius. That's all you need. And you know everything there is about a sphere. Ooh, of course, not going to give you the radius again. I am going to give you the volume, though. I give you the volume. Can you find the surface area? All right, so that 36 pi is equal to 4/3 pi r cubed, and I need your help because we need the radius so I can find the surface area. Your first move to get r by itself. 26, your first move? No 26, we're just going to 26. Going? Okay, thank you for not saying a word, and let me do this awkwardly. 7. Get rid of the pies would be a good idea. 36 equals 4/3 r cubed. Next move. 7 again. Multiply by 3/4. So we get r cubed equal to, sure, I'll risk it. 18. 27. I did talk about this in this unit. I don't take the square root when it's cubed. I take the cube root. And another reminder where that's located, you go to your calculator under math, choice 4. Choice 4. You know what? I'm feeling it today. Let's keep going. What's that radius length? 18 again? 3. Good deal. All right, let's go plug it back in now and find the surface area. And leave this in terms of pi too. Make it easy on us. 3 squared. In terms of pi, what do you got for me? 7? 36 pi. Inches squared. Anything you'd like to ask before this problem we're doing next? This is an old Regents question from a few years ago. All right, straight off of Regents. So you can start seeing the types of problems that are on the Regents exam. Volleyballs, partially inflated one and a fully inflated one. You see the volumes for each? What's the difference in their radius? Okay, I give you the volumes of each. What's the difference in their radius? I'm not going to call on people or anything here. I just want to make sure you notice something in here. So let me do the partially inflated one first, and then I'll let you go and your work in your groups here on this one. Was it 4/3, right? Pi r cubed. So the partially inflated one has a volume of 180. I just want you to take notice of something, because this is, I think, the first time it's happened. What's not with the 180 that I could just cancel out like usual? Okay, so don't cancel out the pi on the right. You're going to have to get rid of it. All right, you cannot just cancel and go, oh, I'm good. The 180 doesn't have one, so that's doesn't work there. So go ahead, you and your group, find your radius of each and see how much it increases by. Talk to each other, it's fine. All throughout the problem, do not round. Do not round anything all throughout the problem. Check those radii. If you're not matching up, a common mistake today has been taking the cube root, and students have taken the square root instead. All right, so make sure we're taking the square root here. That's cube root, not the square root. Nearest 10th. 10th. Increase when you're ready. 21.
0.6.
Thank you. 0.6 inches. 10th. Nothing, anything past there. All right, solid there on that Regents question. Fellas, you good?
Yeah.
You good? Solid? Is he Arash? Is he good? What's going on? From Big T-Bone back there, as the kids on the street call him. You good?
Yeah.
You sure?
Yeah.
I can help you out.
I'm good.
Okay, I believe you. You've earned that credit. I believe you. All right, I do want to go over a hemisphere, though. Cut a sphere in half. We got a hemisphere. The volume, not affected. Surface area, you got to pay attention to, though. So let's just do the volume and get it out of the way. We know it's 4/3 pi r cubed, right? But it's a hemisphere, so yes, if you're thinking cut it in half, you are correct. Or multiply it by a half, it doesn't matter. All right, so let's figure this out so we can get the surface area. 4/3 pi, where do you plug it in for the good old radius here? 4. 14 cubed. Go ahead and round it to the nearest 10th again when you're ready. (5,747 cubic feet). It's a big hemisphere. Unfortunately, that's not what I'm doing for the surface area. We all good so far? All right, surface area. All right, let's talk. So here's our formula from beginning of class today, 4 pi r squared. That's a full sphere. Yeah, you are correct. I am going to cut that in half, but that's not it. It's just not as easy as cutting it in half. And here's why. What's surface area again? Anything on the outside, right? Anything on the outside. 4 pi r squared is just for this. I think we're missing something if we're counting everything on the outside, aren't we? What are we missing? The bottom. And what shape is the bottom? A circle. So not only do I have to cut that in half, that's just the dome part, I need to add in the circle on the bottom. So what should I be adding on to this? Pi r squared. And since you're in honors, I'm going to keep going here. Look, you can just plug in the radius right now. I have no issues with that. But we are in honors here, so I do want to simplify this a little more. This turns into what? 2 pi r squared plus another pi r squared. 3 pi r squared. If you want to remember that, fine. If not, you still have to remember to add on the circle at the end. All right? So surface area of a hemisphere, watch out for it. And what do we got there? 1,847.3 square feet. All right, surface area, everything on the outside. We got to count the bottom and circle on the bottom. All right, spheres, we're done. We're done with spheres. There's one last topic I need to discuss with you, and that's this Cavallari's principle. Basically, you do not have to find the volumes of two figures to know they have the same volume. All right, I do not have to do their calculation, find the volume of one, find the volume of the other, and say, oh, they have the same ones. There's a different way I could figure out if two figures have the same volume. And this was a mathematician, last name Cavallari. Anybody want to throw out first name guesses?
John.
No shot at getting it, but you can.
Paul Zanzibar. Led. Greg. Oh.
Mr. Bonaventura Cavalieri. There you go. Okay, Bonaventura. 1600s, mathematician. Here's what he found. Bottom line, his principle says this. If two figures have the same heights and their bases have the same area, they have the same volume without even calculating the actual number of it. Okay? Same heights, base has the same area. Right? Take a look here. Everyone see, I'm going to call them pizza boxes here. The nicely stacked one, the kind of leaning one, and then just the hot mess. I'm sure you could put yourself in one of three categories here. All right, with the pizza boxes. Why do they all have the same volume? They have the same heights. How do I know? There's 6 of them in each, stacked on top of each other. So they all have the same heights. And what's the shape of the base in each of them? Square, rectangle, and they all have the same area. So that means all 3 of them, even though they look completely different, all have the same volumes. Let me put a stranglehold on this principle. I don't even have to have the same type of figure. Triangular prism versus a rectangular prism. Same volume. How do I know without even calculating it? Same height. And this triangle has the same area as this rectangle. All right, same volume. Don't even need to calculate it. All right, and that is what I want you to do for these next 2. Use Cavalieri's principle and not calculate the volume. Look at these 2 right here, triangular prism and a rectangular prism. Do they have the same height? Same height? Okay. So same height. 13. How about their area of their bases? Even though they're different figures. You just can't say no because they're different. What's going to be the area of this one? How do I find the area of this base on the triangular prism? 8. 1/2, 4 times 2, and that'll give me a base of area 4. What about the next one? The rectangular prism. How do you find that base area? 13? Done. I don't actually need to know what the volume is. Are you seeing that? I can already tell same volume. I don't know what it is, but I don't care. I know they have the same volume because they have the same height and same base area. What about the cone and the cylinder? I think we can stop right away with our discussion. What do you notice right away about the 20? What do we notice?
They have different heights.
Different heights, different volumes. So different volumes because they have different heights. I'm not even going to calculate. I even think if we did calculate the base area, it would be the same. So is everyone all right on Cavalieri's principle? Because then I'm going to do a Regents question with you. They did ask this on a Regents exam a few years ago. 2 stacks of quarters. They have the same volume. Using Cavalieri's principle, why? All right, well, it's got to make sure we do 2 things. Height. How do you know they have the same height? Because it looks like it? That's never been a response this entire year. How do I know they have the same heights, even though it's not even given it to me? Chris? Nick?
They're all quarters.
They are.
And since they're all quarters, they would have the same height.
Well, if I had a stack of 100 versus a stack of 2, they're all quarters.
It's the same number.
Thank you, right? Same amount of quarters. Height, 23 quarters each, right? So I'm guaranteed they have the same height, 23 in each. How do I know they have the same base area? What's the shape of the base? Quarters, right? And don't be the kid. Well, what if one side of it's dinged up a little bit? So the quarters would be... No, just stop. All right, just stop. All right. Same base area. Because the bases are quarters, right? We assume all quarters have the same area. Well, not if we went here to this country. Just stop being an embarrassment. So they would have the same volume. All good? I know you're going to be devastated to hear this, but tonight's assignment at the bottom of the page, your last one out of the textbook for the year. Done. So next Tuesday, in addition to that folder and binder you're going to bring in, you can start bringing in your textbooks if you borrowed one starting next Tuesday. No need for them anymore.
Textbook ready.
Yeah, sure. I'll